Hello everyone, how you doing? So today we are looking at lead code 459. This is an easy problem called repeated substring pattern, and let us jump into the problem statement without further delay. So this problem says that given a non-empty string, check if it can be constructed by taking a substring of it and appending multiple copies of the substring together. You may assume that the given substring consists of lowercase English letters only, and its length will not exceed 10,000, right? So it's like we have to find out if a given string can be constructed of substrings within the string, like appending substrings from that. So looking at this example AB, we can break it to substring called AB and concatenate it twice to form this string called AB. ABA cannot be found because there is no substring which repeating which by concatenating which we cannot form we can never form ABA, right? This string can again be formed by differentiating, like this ABC is the element that can be repeated multiple times, and you can see it's repeated 4 times here, and it forms a string. So true for this one. So this is a very simple problem, looks very simple, but this is a string problem, and this problem was asked at Facebook, Twitter, Airbnb, and LinkedIn. So this pretty much is interesting and also easy, towards the easy side. So let us have a look at how we're gonna solve it. So if you think you want to give it a shot, do pause the video and give it a try. It's lead code 459, right? Okay, so let us jump into the how to solve this. So this looks like if we can somehow break this string. So at first, if we can think of a solution like any string that has length even, that is there. So we have to first think of cases like is there, so this is an odd length string and we can clearly see it cannot be true. This is also an even length string, but let's say this there would have been another ABC, so in that case it would have been possible, right? Because 3 into 5 is 15, so we cannot differentiate on the length, so that is not something we are going to try. What we need to find out that if we can find any element, if we can find any component inside this string by which we can basically concatenate it, which can form the basic element of the entire string. So we need the length of the string and the numbers which can divide the length of the string uniformly. Let's say here the length is 12, right? So we can check by taking units of 2, units of 3, units of 4, units of 6. Why? Because these are the numbers, these are the divisors that divide evenly. So basically if you do a mod of length of the string 12 mod 3, 12 mod 4, 12 mod 6, 12 mod 2, you'll get a 0. So they don't leave any reminder behind, right? So we can check with like length of such strings, and we can check like if every four of them are equal. So when we check, so first four is ABCA, next four is BCAB, so we find out it's not same, and we can break out immediately, right? And we can check with something like length of 6, we can check with length 3. Immediately as we get something, we can return as yes, we got something, right? So we are going to follow that approach, and we are going to solve this problem with that approach. So I'm going to use Python for this, and pretty simply we're going to take the length of the string into a variable, let's say sn. And so handling corner cases first, if length is less than 2, if there is only one element, there cannot be it is always false, because you cannot form any substring which can form that string, right? It's like it's always false, because there is no repetition. There has to be at least two to find a repetition, to try for a repetition. So for length of 1 and 0, it's definitely going to be false. Let us try for other cases. So what if we have a test case like this? Let's say a, where like there is only one item being repeated. So in this case, uh, this is going to be true. So this is a very easy way we can think about that. So basically um, basically we can break this string down to items, like a and another a and another a. So and we can find out how many uniques are there. So we will find only one of them. So I'll use some Python trick here. So we can just do length of the set of the list of the string. So what it does is list of string will break down the entire sentence, entire string into characters, list of characters, array of characters, and then set would convert it into a set. So we'll have only uniques, and after that we find the length. So if there is only one, if this is one, then we can say that it's like return true, right? If it's not if it's not we have to check for every divisor of it. So for I in range, like the range would be from 2, will be starting from 2 to n by 2, right? Okay, n by 2 plus 1, because for Python it takes like up till that range, before that range, yeah. So it will be n by 2 plus 1, because after n by 2, after the middle element, like for 12 we don't need to check beyond 6, we don't need to check 7, 8, 9, 10, 11, 12, because it's pointless. They won't divide it uniformly, they would always leave a remainder, right? So, and we're gonna check if these don't leave any reminder. So if n mod I, if the length mod I is equal 0, and we need to check, now we need to check if it divides uniformly. So basically I can write a helper method, and I can pass the string and the value. If it's true, I'm going to return true, and if none of this is true, we are going to return false. That's it. Now we have to write this utility function, check utility. So this check utility will check a string, and will take a string and an integer and check for all of this, right? Now inside this we'll write a set, because for every item we are going to uh, put it inside every window, we are going to check and put it inside the set. So for I in range, we're going to start from 0, and we are going to end up at the length of the string, uh, and we are going to jump by like every time we are going to jump by the length that much, so I times, so the window we have defined, right? And so basically we are going to add st.add the string whatever is there from I to I plus not I, it should be, okay, we have taken I, it should not be I, it should be something like a k, and it should be I plus k. Okay, this should be st of I and I plus k. Cool, right? So that solves it. And okay, now if any time, if length of st, if it's greater than 1, we return false immediately, and otherwise we just check if length of st is equals 1. That's it, right? That's it. That would help us solve this problem. Let's try submitting this. Great, so we get a success here, right? But I want to discuss another approach that also came to my mind just now while coding this, uh, and I also thought about this approach. So if we can, if so let us, I created a whiteboard for this separately. I prepared a whiteboard earlier, and if you could visualize this problem is very much like this. So let's say this is the given string. So you have to understand this pictorial representation. So this is the string we have been given. Let's say this is s, right? This is the string um, we have been given, and if we could repeat the string, if we could, that's just an operation we are going to perform. If we could append that string with the string itself, if there is no way we can form uh, like a substring inside this, if we cannot satisfy the solution for s, we cannot satisfy the solution for s and s combined together and removing the first and the last character. Do you understand what I say? Basically what I'm meaning is, let's do this operation. Let's take the string s, let's append the string with itself and remove the first character and remove the last character after appending the string, whatever it is, whatever is inside this red region. If you can form an s from this region, right? How in this you can see you cannot form an exact box like this from this much area. So you cannot, the result would be false. But let's take this example, right? This is S, this is S, this is S1, this is S2, whereas S1 and S2 are same, but we are just telling it S1 and S2 for clarity. So S1 and S2 we have it here, and we can see that I can form the entire string. So my entire string is S1 and S2 together, right? S1 and S2 combined together, that is my entire string. But I have visually represented it as in a way that this already is the right answer. So S1 and S2 is a right answer because I can form the entire string by only S1, by only repeating S1, S1 and S1 two times. So now let's see, this is the string, I'm repeating this string again here. So this is S1 again, and this is S2, right? Now let's remove the last character and remove the first character. So what you have is inside this red region. Do you find the entire string inside this region now? Yes, we find it. We find it here. This is the entire string we are looking for. So this is true. That's it. This is a very tricky but very interesting way, and this is how you can visualize this. So we can basically reduce this problem to a very simple way. I'll keep the solution. Okay, I'll just keep the alternate, call this as alternate, and we'll write another function where what are we gonna do is just return if s in s plus s 1 2 minus 1. So what I'm trying to do is, this is s plus s. S plus s is the operation we talked about here, that is appending the string with itself, right? And 1 to minus 1. So in Python it starts from 0 and the last index is minus 1. So I'm telling just leave the first index and leave the last index. Go from the second index to second last index. That's my string. And if s is contained in that, so that's the right answer. So if we try to run this solution, now we are just running this one line, right? And we're gonna submit this. Let's see what happens. We pass, and we get a much better time complexity. So we get 24 milliseconds, and it's better than 99.48% of Python submissions. So that's how you can see, like, a simple trick. If you can understand this, if we can keep this trick in mind, that's how we can solve it much effectively. And this takes only just a linear check, where in this we had to do it a linear check every time. This is kind of towards n square, but like, we are iterating over it, and this is definitely not n, but this is in the order of n, and every check is also of order of n. So this is kind of n square roughly, but this is definitely not n square because we are appending it. This is just like, probably it's very fast, definitely appending one string with another, like, and we are just like checking for one string, so it's linear, easily it's linear, right? So definitely you can understand the time difference, and that's why this is the optimal solution for this problem. And that's it for today's video. I hope you guys enjoyed it. Do like and share if you guys enjoy this video, and like this video if this video helps you understand, get some value. A like definitely helps me to understand, like, if I'm helping you guys, right? So that's it. Hope you guys have a great interviewing experience, and good luck for your interviews.